Close your eyes and think about the emptiest thing you can imagine. Maybe picture a vacuum chamber completely devoid of air, or perhaps the deep, silent void between distant stars, light years away from the nearest galaxy, where there is not a single atom for millions of miles. We instinctively visualize nothing as a blank canvas, a quiet, boring stage where the drama of the universe eventually plays out. But if you ask a physicist, they'll tell you that nothing is actually the most complicated thing in the universe. Physics has a secret. Nothingness is a big deal. Let's perform a thought experiment. Take a box and seal it tight. Now, let's try to create perfect nothingness inside it. First, we pump out every single atom of gas. Then we shield it to block every photon of light. We even chill it down to absolute zero to stop all thermal vibration. You would expect that inside that box, there is absolutely zero energy, a perfect silent void. But quantum field theory says, not so fast. According to modern physics, the universe is filled with quantum fields. These fields are everywhere, permeating every inch of space and time. Think of them like the strings of a cosmic guitar. Even when they aren't being plucked to create particles, they are still under.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
It's called the zero-point energy. Even at its lowest possible energy state, the vacuum is alive. This happens because of Heisenberg's uncertainty principle. It states that you can never know the precise energy of a system for a specific moment in time. This uncertainty means the universe cannot remain perfectly still. It essentially borrows energy from nowhere for split seconds. This borrowed energy manifests as virtual particles, matter and antimatter pairs, that pop into existence and then instantly collide and annihilate. It is a chaotic, bubbling brew of activity. A cosmic party that never ends, happening in every millimeter of empty space right in front of your nose. For a long time, this was just a mathematical theory. But in 1948, physicist Hendrik Casimir proposed a way to prove it. He said, take two uncharged metal plates and place them extremely close together, micrometers apart, in a vacuum. Because the gap is so small, only small quantum waves can fit between the plates. But outside, waves of all sizes are pushing against them. This creates an imbalance. The pressure of the nothing outside is stronger than the nothing inside, pushing the plates together. We have measured this. The Casimir effect is real. It is physical proof that empty space exerts pressure. Nothing literally has muscles. But the story gets even weirder on a cosmic scale. When we look at the universe, we see it expanding. Not only is it expanding, but the expansion is accelerating. Something is pushing galaxies apart faster and faster. We call this force dark energy, and it makes up about 68% of the total energy in the observable universe. The leading theory? Dark energy is simply the energy of empty space itself, the cosmological constant that Einstein once famously rejected. Unlike matter, which dilutes as space expands, the density of vacuum energy stays constant. So as space grows, it creates more energy. This energy pushes the expansion even faster, creating a runaway loop. The void is the engine driving the destiny of our entire cosmos. So, the next time you look at an empty space, remember, it is not empty. It is a seething ocean of potential. And even when you feel like you are doing nothing at a quantum level, the space inside your atoms is incredibly busy. If you could build a universe from nothing, knowing what you know now, what would you put in it?
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.